Okay, so we were talking about alkalines. What do you guys remember about alkalines? I mean alkalines, alkanes.
Has the A-N-E.
A-N-E.
So it's
What else do you
one.
remember about it?
Full bond.
One.
One bond.
Okay, so single bond. Are everything in it a single bond?
Yes.
Okay, what about alkenes?
Double bond.
At
Okay,
least one double bond.
at least one double bond. And what if there's a triple bond? Is it an alkene?
It's an alkyne.
It's an alkyne. Okay, so it has at least one double bond, but there can't be anything more than one double bond. I mean, more than a double bond. Get what I'm saying? And alkyne. Okay. Alkyne means
Triple bond. At least one triple bond.
at least one triple bond. Oops. Okay, simple, right?
Yes.
Okay, so I have a question. Does this pertain to anything other than hydrocarbons? So if I had something like this, let me draw it up there first, and then you comment. That's an O. Would this guy be an alkene?
No,
No.
Why?
Because it doesn't have hydrogen.
Well, this does have hydrogen, right? Because we understand that these here have hydrogens hanging off of them, right?
It doesn't have carbon.
No, we understand that these here have carbon. We talked about this Friday. You got to remember, at each indices, when you draw it like this, there's a carbon here, there's a carbon here, there's a carbon here, there's a carbon there. Friday. I'm sorry, last Thursday.
Okay. I was
Oh, it has
y'all have
oxygen.
That's
Yeah, it has
right.
oxygen, so it's not a hydrocarbon because it's.
Jessica, I'm gonna beat you, not Jessica, the other Jessica. Stop giving them answers.
Okay, I'll stop.
She's helping us, Dr. Henry. She's
What was
helping
that?
us. She's helping us.
That's not helping you. No, that's spoon feeding you. There's no spoon feeding in my class. You guys are not 2-year-olds.
We were taking guesses and we were wrong. She was just giving us a hint. There's nothing wrong with that.
That's not a hint. That's an answer. There's a difference. Okay, so we have, and I'm going to draw a different one. Okay, so we know that this guy isn't an alkene, alkane, or alkyne, right? It's going to have a different name that's associated with it, and we'll talk about it here in a minute. But the first thing that I want you guys to do is recognize that this guy is not an alkene, alkane, or alkyne because it has what again? Somebody said it.
Oxygen.
Because it has oxygen. Thank you, Jessica. Okay, so that means that it doesn't fall under these categories. It's going to have different behavior. It's going to behave similar to these guys because these guys, they belong to a family. They kind of behave a little alike. There are going to be some differences, but for the most part, there are certain things that you're going to say, oh yeah, this is what's going to happen, you know, based upon being this guy. When they're in reactions, this is what's going to happen, right? And that's going to be important for understanding chemistry in general and also understanding organic chemistry. Okay. So let's see, we're going to do a quick run through, see how much you guys remember, and then I'm going to keep going regardless. Okay, so we got this guy. That represents a double bond, single bond, single bond. Okay, what is that? Alkene, alkane, or alkyne?
Alkane.
E.
Alkane?
Alkene
Yeah.
with an E.
E and E.
E, yeah.
Okay, so it's an E
Yeah.
and E, right?
Yes.
So it's an alkene.
Alkene. Let's see.
Okay. This guy. That
Triple
one.
bond.
Alkane.
Alkyne.
Alkane. Last one.
So how many guys think it's alkyne?
Yes.
What about this guy?
Alkane.
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 Alkene.
Okay. So this here, all single bonds, alkane, right? A double bond, no triple bond, E and E, alkene. Triple bond. I know that's an ugly triple bond, but that's a triple bond. Alkyne. You guys get it?
Yes.
Okay. One, all single bonds. At least one double bond. One triple bond. 1, 2, 3, triple bond. Got it? Piece of cake. Okay, so let's talk about how we go about naming these guys. So we're going to start off very simple with single chains, right? Because we could have branches and stuff like that. We won't do the branches just yet. We'll work on that, okay? And Jessica's going to get upset because she's like, you didn't do this with our class. Isn't that right, Jessica?
No, not at you, no.
Okay, so if it has one carbon, only one carbon, it's going to start off with meth. Don't think about the drugs. I know that's the first thing that came to your mind. Ro, I see your face. He's even giggling about it, right? No, don't think about it. Stay away from that stuff. If it has two carbons, it's going to be F. If it has three carbons, it's going to be prop. If it has four carbons, it's going to be bute. If it has five carbons, now so this is when it starts getting to like normal Greek prefixes because these got all fucked up. The rest of it is going to be normal Greek. So 5 is what in the Greek prefixes?
Pent.
Pent. Six.
Is it oct?
Sept.
No, 6 is an oct.
Hex.
There you go. And I'm just writing it. I'm like, sure, we're going to say that. 7.
Is it sept?
Nope.
Pen?
Or hept? Oh.
Hept. You knew that EPT was in there somewhere. 8. Come on, Ryan.
Oct?
Okay. 9.
Oof.
Non?
Nona.
Oh, dang it.
Yeah, so it's known. Yeah. 10.
Deck?
Des.
Oh, sorry.
That's all right. I guess you could say deck. Decking. Yeah.
Mm.
Okay, you guys got it? Yeah? Okay, so we're going to give you a test here. See. Okay, what would be the name of this guy?
Int.
Hex or
So we got 1, 2, 3, 4, 5, 6. So it's going to be hex. And is it double bond, single bond, or triple bond?
Single one.
Single.
Single bonds.
Ane. Because they're all single bonds. Okay, what about if I did this? What is it going to be? Count the carbons.
Hexene.
Hexene.
Hexene. And then if I did this,
Hexine.
piece of cake?
yep.
Okay, so this will give me my base or the root, right? So that's going to be at the end of the name. Now, when we talk about hydrocarbons are at the lowest priority of organic compounds because they're hydrocarbons. They're just straight carbons. So these guys, we may have to change the name based upon the attachments that it has, but you're always going to end up using this root, okay? These prefixes to decide the root. And I'll kind of explain that a little more details because right now, those words are just going in and out of your ear and you're like, what the hell did he just say? Until you see it, it's not going to make complete sense. But remember, priority-wise, these guys, A and E, lowest priority. E and E, second lowest priority. Y and E, third lowest priority. So they're at the bottom of the totem pole. But Y and E is more important than A and E, so it has preference, right? So if we had a double bond here, we always end the name in Y and E. But we have to let people know that it has a double bond in it, right? Wouldn't that be fair?
Yes.
Okay. So we also have to pay attention to where things are located at, right? So the triple bond is located between here, between which carbons? So if we started one, let me change the color, sorry. So you guys don't think I'm writing another crazy chemical formula.
Would it be between 3 and 4?
Okay, so it would be between 4 and 5, wouldn't it be? All right, let's do the count.
Oh,
1, 2, 3, 4, 5, 6. Okay. So if we started with this as being our first carbon, right?
Mhm.
The triple bond will be between your 4 and your 5. So
Oh.
you would use the smaller number, say it starts at the 4 position. Okay. However, because we can flip our orientation of this, this is one way of looking at it. The way that we're looking at it, it's like this. We can flip it so it looks like let me fix that. You guys can't see over there, right? Because your thingies are over there. Can I erase this over here? You guys got this down? I need a
Yes.
little more room. And I want to keep that meth and stuff up for a second. I may type it to give me a little more room in a second. Or can somebody type it for me?
To type all the different.
Yeah,
I can do it for you.
okay. So while he's doing that, I'll keep talking. So somebody may have to update him.
Do you want me to type it on the left-hand side or the right-hand side?
Type it on the left-hand side. Put it in the black space. So usually color that will go good with black.
Okay.
Okay. So we have.
Dr. Henry,
Yes, sir.
morning.
Good
How
morning.
how can you go? Number 6. Yeah, you go at zinc. Where you get at zinc from? The Y and E.
Because there's a triple bond.
So triple bond called at zinc from. Okay.
Yep. 6
Okay,
carbons. Yep.
Okay, from
And a triple
archive.
bond. Yep.
Okay. So you get the last word from the. Okay. So that means 6 and 3. 6 and triple bond. Triple. Okay.
Okay. So you see how I flipped it? It's the same structure. I just turned it, right?
Uh-huh.
So you always want to put the item that has the highest priority on the lowest carbon. So if we count it this way, 1, 2, 3, 4, 5, 6, then our triple bond is located on the second. It starts on the second carbon. Do you guys get that?
Can you say that again a little bit slower?
So you want to put, let me type it out, and then as I say it, to put the it's called functional group. So you want to put the functional group with the higher priority on the lowest carbon. Okay, so if I numbered it from here, if I said this is 1, 2, 3, 4, 5, 6, then my functional group is going to be on the 4th carbon. If I do it here, 1, 2, 3, 4, 5, 6, then my functional group is on the 2nd carbon. Do you see that? So to put it another way is, this is in orange. You see the orange coloring? That's 1. This is 2. This is 3. This is 4. This is 5. This is 6. So I have the option of having my first carbon start at this end, or I could have it start at this end. But the way I choose which way I'm going to start my first carbon is to find out which one has a functional group. So that triple bond acts as a functional group. Okay? Do you guys get that?
Yes.
Okay. So 1, 2, 3, 4, 5, 6, which is what I'm showing over here. So my triple bond starts at the second. So the way I would actually name this would be 2 hexyne. So that tells me that the triple bond is starting at the second and ends at the third carbon. That location, that 2, tells me where it's at.
So you're always gonna look for the one with the lowest carbon?
For priority. So there's going to be a priority list, and I'll explain that priority list to you here in a second. Okay, so far, what is your priority list? Who's on the bottom? Alkenes, alkanes, or alkynes? And I want you guys.
Alkyne?
Okay,
Alkene.
so you said alkyne. Lowest priority,
Alkane.
alkane. And that should give us a hint, because do you see anything that says alkane here? So that's the lowest priority. We don't even mention it, right? Unless it's the only thing that's there. Okay. And then
Alkene.
alkene. So let's say we have something like this. Okay. Okay. So what are we going to name this guy?
Okay.
How many carbons do we have?
We have a
7.
triple bond.
7.
Okay, so we have
7.
a different color. 1, 2, 3, 4, 5, 6, 7. So then my root is going to be
Yep.
hept. So is it going to be a kene, En? Is it going to be a alkane, or is it going to be an alkyne?
Alkyne.
Alkyne.
So I'll put YNE. Okay. So shortest distance. If I start at 1 here, 1, 2, 3, 4. Oh, it works out. 1, 2, 3, 4. Same either way.
Hmm.
So it's going to be 4. And then the double bond, right? We have to take account for that double bond. We're going to put it in its lowest spot. Well, even though this is going to be the lowest possible we can get is 4. So that just kind of works out. So we have the option of making it a 1, or we have the option of making it a 7. So you always want to try to get the lowest number possible. So then what we would do is go 1 dash En dash. So that En, and of course I erased it, comes from
Okay.
alkene. That's right. So when it's not a priority, so can I underline? God, I can't do all the things I wanted to do. So when it's not a priority, then what you'd have to do, but you want to show that it's there, you want to put just that En to let us know that that has a double bond. And that double bond is located in that first one. You see that, Kayla?
Yeah.
would we ever have one that has all three?
Well, it does. You never, in the case of this, you never have to put the A and E because you're telling me I have 7 carbons. Only one of them is a double bond, and only one of them is a single bond because I only have one number here. Okay, do you guys see that?
Mhm.
Okay, but the question that you should be asking me next, what happens if I have like 3 triple bonds and 2 double bonds? Oops, did I erase my answer? Is that the next question that you're going to ask me?
Sure.
That one, or if the bonds were switched, would you still, like, so 1 EN, would you put, say the triple bond was first, would you put 1 YNE?
No, because the triple bond has priority, so it's going to end with the triple bond.
It will always end with the triple bond?
It's not going to always end with the triple. It just depends on who has priority. You're going to get more stuff, so I'm not going to say always, right?
Okay.
So priority-wise, so we have, so far, this is what we have. At the very bottom, we have AL, the alkanes, okay? We have alkenes,
Okay.
and we have alkynes. Oops, sorry, alkynes. There we go. Okay, so the ending, you see the ending here? The ending is designated by priority. Do you guys get that? So the ones that are who's most important get to put the ending. It's kind of like the last name. You know?
Okay. So even
Since
though there's like a double bond there, it would, because there's a double bond and a triple bond, it will end with the priority.
That's right, which is the
Okay.
triple bond.
I see.
Yeah. So like we're in a patriarchal society, right? Your last name is, the women typically take the man's last name, right? Am I wrong?
No, you're right.
Right.
Okay, I'm like, wait a minute. Last I knew that was the case. Not to say that that's right or wrong. Don't get me wrong. I'm not saying that. I'm just saying what it is, right? It is what it is. I'm telling you the truth here. So it's just like that. It's priority. And so because we're in a patriarchal society, we say the man has more priority than the woman. So that's why we have the man's last name. If we're in a matriarchal society, the woman would have more priority, and then we'd have the woman's last name, right?
Mhm.
So that's the same thing that's going on here. You guys get that?
Yes.
So think of it like our society, and that's the way it's kind of made. Okay, so let's give you guys one more, right? So you guys can, I'm gonna test those boundaries here. Okay, so what are we gonna have here?
8.
Okay, so oct what?
Pain
Okay.
or in, I mean.
Mhm.
Okay, so how do I tell about the carbons? Where are they located? Where are the double bonds located?
Well, you have one at
The
1.
one.
You have one at
And then
4,
4 and 7.
6.
6.
Oh, 6.
Okay, so the way that you would do this is if I can get it. So I'm going to show you 2 ways that it's done. Oh, come on, if it lets me. Okay, so 1, 4. Okay, so it'll be 1. It should be 4. 1, 4, 6 octene. Or 1, 4, 6. One, four,
There's
6
3.
octene or 1,4,6 trioctene.
Try because there's 3, right?
Yep. Okay. So let's say I did this. I'm going to take, let's go. Okay, how many carbons?
8,
8.
9,
Sure.
9.
9.
1, 2, 3, 4,
9.
5, 6, 7, 8,
9.
9.
Okay. So 9 would be what?
Non.
No.
Okay. So what would be the base?
Alkene.
Alkene.
Okay. Where is that located at?
Number 1, number 3, 5.
I kind of set you
Yeah.
guys up. So where should I have started counting from?
From the back?
From the right.
So that's right, from the back. 1, 2, 3. That's a horrible 3, I know. Let me fix it. 3, 4, 5, 6, 7, 8, 9. Okay, so where's the triple bond located at?
3.
2,
Or 3.
Who said 2? Somebody own up. I heard it.
I did.
I'm not that old. 2 is correct. 1, 2. So it starts at 2. Good. It goes from 2 to 3, right?
Oh, I thought those lines were going from 3 to 2.
So
One more time, Dr. Henry. Why are we starting on the 9 on this one?
because you want to go, who has higher priority, the double bond or the triple bond?
Triple bond.
Triple bond has higher priority.
Okay.
It's on top of the single bond, right? So it has the highest priority. So you want to make sure that that has the lowest number.
Okay.
Okay. The guy who has the highest priority has the lowest number.
Okay.
Okay. Okay. So how many double bonds do I have?
1, 2,
3.
3, 4,
3 double bonds.
3.
I have 3. So I'm going to put my E in, and then there's 3 of them. So we're going to say tri. And you can put a dash or you don't have to put a dash. And where are they located at?
You start from the bonds.
4,
And
4, 6, and 8.
No,
4,
3.
6, and 8.
that's-
E, N. 2.
Okay. You guys see that? Okay. So how about I give you guys a couple of them, and then
And change a different style, different kind.
yeah, we can see if you guys can get started. Okay, and then we'll come back together and then we'll discuss them. Is that cool?
Yes.
Yep.
Before we go on to the next functional group. Okay, so somebody's got to take a picture for each team, for each group. So everybody take a picture so that you'll be ready. Get your phones out. Go grab your phones. Okay.
Oh,
No yawning yet.
hungry.
Oh, I know. I haven't had my shake yet. I'm just getting started with my coffee. Okay. So those are your questions. So first 3, name them. Next 3, draw them. Oops.
Do you want me to draw it out, the ones you had, Dr. Henry?
Yep.
Okay.
All right, Dr. Henry, you gonna tell us the name of these since you deleted your annotation?
Are you gonna make me name them now? Huh? Is that what you're telling me? How about we go through it together? You guys can help me out.
Okay.
Sunday, Mondays. Where's my glasses?
Okay, that's a good start, Ryan.
Okay.
'Cause these are the three that we have.
Yes.
Okay, so let's go through it. So where am I gonna start? Oh, you're good. Oh man. Okay, let's start with the very beginning, the first one. So what is the first thing that I want to do?
Count your carbons.
Count my carbons.
Yes.
Does it matter where I start?
No.
No, since they're all single bonds. Oh, hold on.
Okay, so what am I gonna name this guy?
I thought the one you drew had 9 because
Wait,
I got
I'm
non-ane.
Oh yeah, sorry, Dr. I drew that one wrong.
So he's
That
giving
last-
us an extra?
Yeah, that last line isn't supposed to be there.
Okay. Let's use blue again. See, Ryan was just trying to challenge you guys, that's all.
I know. Dang, Ryan. I'm trying to make us look bad. Just kidding.
Okay, so what is gonna be the prefix?
Non,
One.
non, and then
And then
A-N-E.
Non-name, right? No name. Okay, piece of cake?
Yes.
Yes.
That one's so easy, right? Okay, what about this guy? What am I gonna do first?
Count your carbons.
Count my carbons.
But from right to left, I
From
think.
right to left.
So why are we going from right to left?
Because there's a
Because you're
triple
Because you
higher
have a triple
priority.
bond.
Priority, that's right, because the triple bond has priority. It's top dog. Okay, so then what do we have? What's the name?
Would it be
X sign?
Oops. Okay,
but then you have one double
One.
bond and it's on the 5. So it'd be 5 and then
dash.
dash EN dash
Dash.
1.
Dash
X
1,
sign?
dash, yeah.
okay. Piece of cake?
Yes.
Yeah.
Dr. Henry, what does
Yep.
the N stand for?
The EN stands for double bonds. Remember, double bonds were alkenes. So let me see. So when it's not the ending, when it's like it's not the last name, it gets a shorter prefix, right?
Okay.
Okay, so like ENE means EN is going to equal alkene, right? And YN is going to equal alkyne, but that's when you get to higher priorities. So when they're not last names, when they're not in this part, that EN just means it's a double bond. So you have a double bond there.
Dr. Henry,
Yes.
but would you ever shorten YNE because it has the most priority?
Yes, because there are other things that have higher priority than that.
Oh, okay.
So that's why I said don't get attached to these guys only. There's more to come, right? We're
Okay.
building. Okay. So in terms of priority, we'll also put this in priority. Hold on. Stop me do what I want to do. Let's see. Put it in priority cases. Okay, if it's just the base, so this is if it has to come up before. If it doesn't have priority, you use this shortened version. If it is the most priority, you use YNE. You guys understand what I'm saying here?
Yes.
Yes.
Yeah.
And I'll try to put it in some type of English language for those who are going to watch the video later.
Oh my gosh, son, seriously?
Not priority. I can spell priority. Oops. I changed the color. Oops. Okay. Hey, you guys get that? Make sense now?
Yes.
Even though I think I misspelled priority. Didn't I tell you guys this wasn't in the English class?
Nope.
Is it? No, it was right, huh?
Yes.
Just doesn't look right to me. I don't know why.
I need food.
That could be it. Although I did eat a little bit. I ate a little bit of jerky. Okay, so does that help you?
Yes.
Okay, now let's do this last one.
Count your carbons.
Okay, count my carbons.
Yes, but from right to left.
Okay.
So then you're going to start off with the double bond, which is 6.
Okay.
6-En. And then -2, because that's where your triple bond is.
Okay.
And then -nonine.
Okay. Good job. Okay. So what about these guys?
So you would have to write the amount of carbons.
Okay.
Or draw out the amount of carbons,
Okay, so let's do that.
which is 8.
8 carbons?
Yes.
Come on. It's giving me a hard time here. It's funny, it works for a minute and then it starts doing crazy stuff. So that's 1, 2, 3, 4, 5, 6, 7, 8.
Yes. And then it says that you have a double bond on 2 and 7.
I have a double bond at 2 and 7.
Yes.
Okay.
So for this one, I think you would go left to right.
Okay.
Yes. So you would have one line there and one going from the 7 to the 8.
Okay, so that's 1, 2, 3, 4, 5, 6, 7 to 8. Right here?
No, from the bottom up.
Okay.
Yes.
1, 2, 3, 4, 5, 6, 7, 8. Okay, so you're saying right here.
Yes. I don't know if it would go on the inside or the outside.
It doesn't matter.
Oh, okay.
It would mean the same way. If I put it here, that would have been fine.
Okay.
That would have been fine if I stuck it there. Just erase this. Although it would probably look better if it was a straight line instead of look like that I was doing crack when I did it. Okay, piece of cake.
Henry,
Yes.
you know the last work, 257, the din. Din is the name when you have double bond. That's why you put din.
So actually, you guys are right. This technically would have been the wrong nomenclature. That's what you're asking me, right? Because that would be 1, 2, 3, 4, 5, 6, 7, 8.
8.
Yeah, so I should have put it in a different spot. So the name of this would be wrong.
Right.
So I should have made it a 6. That's what I was trying to do. But so then you'd have options. So let's say it was. Let's see if I can fix Ryan's. My bad. That's what I was trying to do, but so in that case,
It would switch.
so it didn't necessarily matter the order that you stuck it in.
Right.
Yeah, the other way, the name would have been wrong. It would have been 1 and then 6. Because that would be shorter numbers.
Right.
Let me make sure that the rest of them work out. Oh yeah, the other ones work out. But the way you drew it right would be right. It was just my mistake with the name. We were just talking about mistakes, Jessica and I. Okay, let's do the next one.
So you would draw the amount of carbons,
Okay,
which is 8.
see if I can get this guy to behave. I don't know why it does that. It just does not want to behave for me today. Okay, hold on. Is that line too light? Hold on. We'll fix this. Too thin. Okay, and then
it's telling you that 2 has a triple bond.
okay. Okay.
And I think that's it.
Okay. What about this guy?
Would you put another bond between 7 and 8?
Okay. For this one here?
4 and 6.
So you would draw out your 7 carbons.
Okay. 1, 2, 3, 4, 5, 6, 7.
Yes.
Or is that 8? Let's see. 1, 2, 3, 4, 5, 6, 7. That's 8.
That was 8.
That's 8 now.
One, 2, 3, 4, 5, 6, 7. There we go. Okay, and you were saying, Matt? I'm having a hard time hearing you guys.
Put another bond between 7 and 8?
Another bond between 7 and 8? So single bond, double bond, triple bond.
No, one,
Triple.
two,
Triple. Okay. So then you're saying you're counting from here. 1, 2. That's what you're saying.
1, 2.
Are we on the 4, 6?
Yeah, 4, 6, die. So remember, you want to start, this is 2, so start from the number. So if we start at 1, 2, 3, 4, 5, 6, 7,
Ikaw backward to.
right? Because it's a heptene, right?
Okay, so we go code 1 from the right side.
So from
So-
right to left.
So triple bond, where?
Starts at the 2.
At the 2, okay? And then,
No. How can I make 1 this way?
where's the double bonds going to be?
No, so
It's 4
And how many do I have?
1.
4 and 6.
2.
I have 2 double bonds. Where are they going to locate at?
4 and
first one.
6.
Between 4 and 5.
Between 4 and 5 and 6 and 7.
Okay, that's it. Good job. Piece of cake?
1. Oh.
And the last one?
You
Yeah,
have 7.
7.
Yes.
1.
Okay.
1.
And then it says you have a triple bond on 4. So, yeah. And then you have a double bond on 1.
Yes. I made a mistake here too. I'm on a roll. Hept is 7, right? 1, 1, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So technically it should be 3.
It's going the other way.
Yeah. So, boy, it's really easy to make these mistakes here. See, I'm a little rusty myself. So that should be the actual name. So if we start it,
5.
1, 2, 3, 4, 5, 6, 7.
7 is
It
4.
would be
Oh,
3. It would be 6 EN
Okay.
and then 3 heptene.
6 EN
Right.
3 heptene. Piece of cake?
Dr. Henry, I have a question.
Yep.
In all of this here, I know I'm able to locate where the carbons are.
Mm-hmm.
Know if it's know how to set the priority.
Yep.
But what I don't understand is how to locate, how to get the bonds, like having the bonds on different numbers,
Okay. What does YNE mean?
Like it has a triple bond.
Okay. So that tells me that the triple bond is located at 2.
Mm-hmm.
Right?
Yeah.
What does EN mean?
Double bond.
Double bond. So di means 2. So di EN means that there's 2 double bonds. So, and they're located at 4 and 6.
Yeah.
And then everything else is understood to be single bonds. Is
Okay.
it okay?
Dr. Henry.
Yep.
So for the 4,6 diene and the 2 heptine, would you read it from right to left because the triple bond has priority?
Well, you can draw it. When you draw it, you can always draw it starting from the 1 carbon. The orientation doesn't matter because it's the same. It'll be the same either way you draw it.
This one.
You understand?
Just
Yeah, it's just
Okay.
flipped. Yeah,
okay.
yeah. So I always like doing it from left to right because that's the way I read is left to right. So yeah.
Okay.
But if you do draw it backwards, just make sure that you tell me, oh, that's the 1 carbon. So I don't think that you guys don't understand that that's the 1 carbon. So number your carbons. If you get something like this on the exam. Okay, how are you doing so far?
Good.
So are you guys ready for me to bust your world a little bit?
No.
Okay. Well, it's gonna have to happen.
No, but you're gonna do it.
That's right. Okay, so let's talk about our prefixes a little bit, and then we'll move on to some more functional groups. So you guys have been introduced to all of the hydrocarbon, pretty much the double bond, single bond type of functional groups, right? So sometimes we have what we call branching occurring with these carbons. So I'll give you an example. I'll show you an example. Okay, let me see if I can almost draw a straight line. Okay, so this is called branching, where you have carbons coming off of carbons, right? So you have this group coming off of this chain. And so when you do nomenclature, what you're going to have to do first off is find the carbon that has the longest chain. And that's going to be your very last ending. That's going to be at the very end of the name. So help me count the carbons here. We're going to count them in red and then another color. So let's count starting here. That's 1. Count with me.
2,
We'll
3,
finish this one. Okay.
4,
4,
5,
5,
6.
6.
And then we're going to stop here for this one. Okay. That's 7. Or we could have went over here 7. It's about the same. Okay.
Right.
So let's do one in the green. Let's not use green. Let's use blue, baby blue. So starting from the same side, 1, that's going to be 2, that's going to be 3, that's going to be 4, that's going to be 5, that's going to be 6. Okay, let's do one in brown. Again, 1, 2, 3, 4, 5, 6, 7, 8. And let's do orange. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, which one is the longest chain?
That orange one?
Orange one. Okay, so the orange one is going to be your root chain or your base chain. Okay, so since it's the biggest, so then that's going to be at the very end. So if it's all single bonds and it's 9, what is going to be the name?
Non.
Non.
Non what?
Non.
Chain.
nonane. Okay. Okay, so we have nonane, and then, so I'm going to go ahead and erase all of the other numbers to kind of keep us from being totally confused. Oops. Okay, so now we have coming off the, oops, Control Z. Coming off the fourth chain here, we have 1, 2, a carbon that has 2 chains associated with it. So the way that we would represent that, do you guys remember? We have meth, we have nth, we have prop, we have bute, we have pent, we have hex, we have hept, we have oct, known, and
Deck.
okay. Okay, so we have all of those, right? So we have 1, 2, 2 carbon change. So the beginning would be what?
F.
Okay, so since it's not a main group, what we're going to put on it, we're going to type it out as ethyl. Okay, we put YL. So that just means that we have 2 carbon chain that's attached to that point. It's located at the 4th carbon, so we're going to put 4 ethyl. We may have to change it around once we get our orientation right, because it's all going to be based upon where the functional groups are going to be at. Okay, so over here we have 2 carbons that are coming off of here. We have 1 here and 1 there. So they're each only a single carbon, right? Because that's 1 attachment here. So what is only a single carbon? What is it?
Oh, meth.
9.
Meth. Okay. So now they're both at the 7th carbon, right?
Right.
So we would write 7, 7 dash, there's 2 of them, di methyl.
Oh, wow.
Okay.
Right.
And then the last part would be nonane, right? Ethyl has priority over methyl, so you would start with ethyl being the lowest number it can be. It can be at 4, although if we count it the other way, 1, 2, 3, the dimethyl would be at 3. Okay, so you guys get that?
I was lost. I don't know, like.
So this here, let's put it in a different color. That's 1 carbon, that's 2 carbon. So there's 2 carbon chain that's coming off of the 4th carbon. This is the 4th carbon right here.
Okay.
Okay, so this is the 7th carbon. That's only a single carbon. We have 1 carbon, And then this guy is also just one carbon, right?
Is it because it doesn't have like another branch?
That's right. It's
Okay.
only a single right here. That's a single carbon right there. So you have seventh carbon is right here. You have a single carbon that's coming off of it, right? So you have a methyl group that's going to be coming off of there. And then you also have another methyl group that's going to be coming off of there.
Okay.
Okay. So let me show you what that's going to look like with carbons. Would that help?
Mm-hmm.
Yes.
Okay. So let's draw we have, and it's not going to be the branching thing. We'll just draw our 9 carbons. So that's what, 3. Is that the baby or was that one of you guys? Don't start crying.
It's okay.
That was you? I knew it was you. Okay, so here we have, let's see. On the 4th carbon, we have a 2-chain carbon that comes off of it. So that's carbon, carbon. On the 7th carbon, we have let's see, that's 6, that's 4, 5, 6, 7. So we have a carbon and another carbon that's coming off of it. Okay, so now we get to add our hydrogens.
Hydrogen.
Remember, carbon can have 4 attachments. And since we're working with hydrocarbons, we know that if it's not carbon, it's going to be hydrogen, since it's only carbons and hydrogens. That's the reason why we can do this. First, I have to use the longest molecule as possible just to give you an example, right?
Appreciate it.
And one more. Wow. Oh, that looks nice now.
So do all of the carbons have four attachments? Or at least almost?
Almost, yeah.
Thank you, Judy.
Perfect.
Okay. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives me my 9 chain. That gives me my no name. So I'm gonna put that in our purple, circle it. Main chain. How many carbons are here?
2.
Okay. So this here, this group is called the ethyl. 1, 2, 3.
So I guess my question is, why is it referred to the ethyl group?
Because how many carbons it has?
2.
And it's branching off of the 4th carbon. So tell me where it's branching off. Because otherwise you won't know. If you just said, because there's a total of how many carbons, count all of the carbons here.
13.
13, okay? So there's a total of 13 carbons. So are they all connected in a single line together?
No.
Or do you have some that are branching off?
Some branching off.
Okay, so you have some branching off, so you have to tell me that you have some branching off. So you want to always find the longest chain first, and you want to write this down. Find the longest chain first, and then after you get the longest chain, then you want to find the one that has the second longest chain. That is going to have priority, okay? So how many carbons is this here?
1.
Okay, so we'll do that in. And then how many carbons is this here?
1 as well.
Okay. So they're both located at the 7, so that takes care of that one. And that takes care of the one that's in orange. Okay. So does that help?
That makes more sense. So you're still using the same prefixes as previous.
Yes. And
So-
then the only thing that we're saying is that by using the YL, we're saying that these guys are coming off of other carbons.
So when you add the YL, it means it's coming off.
Yeah, it means it's coming off of something.
Okay,
general.
that's what the part that kind of lost me, but now that makes more sense now.
David,
Hi.
are you there?
I'm here.
Okay, so you know my next question.
No.
You don't know my next question? My next question is, so David, do you understand? We have 2 carbons. 1, 2. So then we'll use this, we'll add YL to let me know that it's coming off of the main chain. Okay? This one has 1 carbon. So we use meth O to let me know that it's coming off of something. And then since there's 2 of these that are independent that are coming off of the 7th carbon, then I have to use dimethyl, 7,7-dimethyl, nonane. Okay, my main chain is a nonane. On my main chain, I have one that's coming off of, I have an ethyl coming off of the 4th carbon, and then I have dimethyl coming off of the 7th carbon. And again, my long chain is 9. You guys get that? Okay, so you want to give it a shot? I'll leave this example up to help you through it. Let me draw something.
Wow.
So you should initially draw out your carbons first.
You draw up the main name first.
Okay.
Dr. Henry, I have a question.
Yep.
So like, you know the drawing with the green drawing that's right there that you just drew?
Yep.
Like under the 4, it's 3 carbons, right? Or 2?
Here?
Yeah.
That's 1, 2, 3. Yes.
Because I'm confused because like when you did the other drawing with the C's and the H's, you have 2 carbons.
Yeah, because the chain here, this chain here, this right here, let me give you, I'll put it in the same colors so you can see it. Hold on.
Yeah.
Erase. Okay, so the red represents the red here. The orange represents the orange here. The green represents the green here. And then we draw the blue, or purple, or yeah, purple. This here is my longest chain. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons. If I started from here, 1, 2, 3, 4, 5, 6, 7, 8. That would be 8 carbons. That would be shorter than 9. So then I chose this to be my longest chain. So that's going to be this part here in purple.
Oh, okay. So the ones under the 4 like count for the whole thing, right? Like the 9?
That's correct. Yep.
Okay. Okay.
Yep. Okay. So oops. Ah, crap. Okay, so what is my first step?
Didn't you have to number them?
Okay, first find the longest chain, right?
Yeah, for the long chains.
The longest chain. Who's going to be my longest?
I think this is kind of also where I'm kind of confused, is how you number them.
Just count. I mean, you can start anywhere that an N starts and just find which one is going to be the longest. Which one looks longest to you? Actually, I'm not going to do this. You guys are going to do this.
Do it. You have to do it.
What was that?
Can we do it together?
Yeah, you can do it. We're going to do it, but I want you guys to do it. I want you to find the longest chain. I'm not doing it. Who's going to volunteer?
3, 4, 5, 6, 7, 8, 9,
I'm
10.
trying.
1, 2, 3, 4,
Oh no,
5.
Andy's trying.
The straight line, good.
You said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here.
Yeah.
Go this way. 1, 2, 3, 4, 5. We know that's not long enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. 10 is still longer. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 10 is still longer. So my longest chain is going to be
10.
10. So what does that mean?
There's 10 carbons.
Okay, so then what does that mean?
That's your longest chain. That's your first priority.
That's your first priority.
That has my first priority. So then I put that one at the very end, right?
Yeah.
So what will I call it?
Decking.
Decking.
Okay. Okay, the next part, what's going to go in front?
Can be.
Is that going to be?
Isn't there gonna be a methyl off of 7?
Okay, so here's my question here, right? So we figured out my longest chain. So do I want that to be my first carbon, or do I want that to be my last carbon? This one here.
Last,
Why?
because it's further to the right.
That's not the reason why. Do you understand what I'm asking you?
Because of the.
Not necessarily.
Okay, do me a favor. Count where is the first place that you have a branch?
After the, is it after the 3?
So that's 4. Is that what you're saying? 4?
Yeah.
The fourth carbon? Okay, so the fourth carbon is where I have a branch. What is that branch? Is it 1 carbon after it, or is there 2 carbons, or is there 17 carbons, or is it a chain of 1 or a chain of 2, or what?
1.
1. Okay. Now, if I started with this being 1, this being 2, let me put it in a different color. If I said this was 1, this was 2, 3, 4. Then this would be 5. This would be 6. This would be 7. This would be 8. This would be 9. And this would be 10. Okay? So I have a 1 carbon chain off of it here. What do I have coming off of the one here, the 7th in green?
2.
I have 2. So is 2 bigger than 1?
Yes.
So who's going to have priority?
The 2.
2.
The 2 chain is going to have priority. So we're going to go from right to left. Do you guys understand that?
Right.
So let's erase the green. Oops. It just does not want to work with me here. There we go. Okay. Do you guys get that so far?
Yes.
Okay. So then, what were we? So we had.
So we're starting on the right side because we have more carbon branching off on the right side than the left?
We have longer carbons branching off on the right side than the left.
Okay.
Right? Because that's 1, 2 carbons, where this is just a 1 carbon.
Okay.
Okay. Okay, so then I'm going to say, where's those carbons and how many are there? Let's count. How many, what's the size of the carbons branching off here?
2.
2.
Okay, so that's wrong color. That's 1, 2, and this guy?
1, 2 as well.
Okay. Okay, so then what am I going to call that?
2.
4
4 ethyl.
di, 4 comma 4 di methyl? Or no, diethyl?
4 comma 4 diethyl. Okay. And then these carbons, or these carbons here, how many carbons is hanging off of 5?
1.
So then what would I write?
1 methyl.
5.
Oh, 5.
Methyl.
5 methyl. And then I have how many carbons hanging off of here?
2.
1.
So what would I write?
Would it be 9,9 diethyl?
7.
That's a 7.
Oh,
Stop making fun of my writing.
sorry.
So-
So would it be 7,7 diethyl?
Is it ethyl?
Methyl. Dimethyl.
Oh, methyl for this one.
So I would actually put it here. I put 7. Oops. 7. 7. Now, how many methyls do I have altogether?
2. Or 3.
Altogether, there's 1 methyl group, there's 2 methyl groups, there's 3 methyl groups. What is the prefix for 3?
Try?
No, that's for carbon chains, right?
Try.
These are individual methyls. So if I have di is 2, then what is going to be
Try.
tri? And if it was 4, I would put what?
What?
If there was 4 methyl groups, I would put what?
Tetra.
Tetra.
Tetra. Did you guys get that?
Yeah.
Yes.
Sorry for covering my face. I just couldn't. 1. Okay. Do you see it?
Yes.
Okay. So if they're at different locations, right? I could have 5 methyl groups, right? If I had 5 methyl groups, let's say I had 2 more somewhere else, then I would say penta, because that's the prefix for the normal prefix, Greek prefix. So these prefixes all stand for just the carbons only. You know, that's how we get the butyl and all that stuff. That's just for the carbons. Okay? You guys get that? Understand that?
Yes.
But when we're talking about the quantity, then we use the normal Greek prefixes. So you could actually have something that says penta, let's say 5, 6, 7, 8, 9, 10, pentamethyl decane or something like that. You could have something like that. Okay, how you doing? Are your brains fried?
Yes.
Yes.
Yeah.
I just need more practice to understand it.
Don't worry, you're gonna get it, I promise.
Yes,
Okay.
I'm hungry, so I'm sidetracked.
Okay, so that's how we handle branching, right? So you guys have an idea about branching? Are you guys ready for me to introduce you to some more functional groups? So you know the double bonds, the triple bond, and of course the single bond. You understand how to do branching to some extent? Let's talk about another functional group. So we have the halogens. Hala.
Hala, hala. Oh my God.
This is a lot of material in one day.
What was that?
I said this is a lot of material in one day.
Now the halogens are the lowest.
So 4.4 diol.
So your halogens are your lowest one on the priority scale. So the way you deal with halogens, all you're going to do is put an O on them, right? So you have, so they're never going to have a, we should say, So for instance, start simple. Okay if I start simple, or do you guys want to start hard?
Simple.
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 Okay, good. Okay, give myself a little room. So let's say we have something like this. You go through the same way that you would name it. How many carbons? What's the longest carbon chain? And this basically means that you have a bromine group hanging off of it.
5.
So that's 5. So what would we call 5?
Pentane.
Okay. Okay, we have 1, 2, 3, or 1, 2, 3. So it's off the 3 carbon. So then you would say 3 bromo pentane.
Bromo.
Bromo. Okay, what would this guy be? That's a Cl right there.
5. So that would be
Pentane again.
It would be pentane again.
Are you sure? How many carbons are there?
1, 2, 3, 4. 4.
Okay, so 4 would be what? Is that
Butane. Butane, and then 1, 2, 3, 4. Oh shit. 1. I don't fucking know.
So we have,
Could be chloro.
that's right, chloro. Where would it be located at?
The 5 branch.
Ooh, would it be the 5 branch? So you said 1, 2, 3,
That would be
4 carbons, and then it's attached to the chlorine.
So 4.
Or
Cool.
this would be your first carbon. This could be your, let me put it in a different color. Sorry. I'm glad that they have multiple colors. It would make things so much harder. Okay, so that's. Okay, so 1, 2, 3, 4, or 1, 2, 3, 4. What would be the shortest distance for that?
1.
1.
Okay, so then that's what it would be called.
Methchloro.
No, where's
I mean,
where's
1.
it in
I'm
the
sorry. 1 chloro.
1 chloro. Okay, so that would be your first carbon. This here means that it's attached to the Cl. Like this guy means it's attached to that. Okay, you guys see that? You want to try one more?
Yeah.
A totally different one.
Oh, let's make it a little interesting.
Ah.
Oh, let's make it a little more challenging.
Oh, great.
Oh Lord.
Okay. And that's a double bond here. Okay.
Okay.
Longest chain.
1, 2, 3, 4, 5, 6, 7, 8. I counted 8.
I counted 8 as well.
So did I.
1, 2, 3, 4, 5, 6, 7, 8.
Dr. Henry.
Yep,
But wouldn't you count it from the opposite direction since we have a double bond?
you are correct. See, you guys make me so proud.
Hmm.
Yeah. Yeah.
See, now do you guys understand why it's important to make mistakes?
Yes.
Yes.
Yes. One, two. One, two. Okay.
Mm-hmm.
Okay.
Okay. So then my base is going to be what? Last part. I always like calling it the base.
Oh.
Oct? Oct what?
Bean.
And how do I tell where that is located at?
On the 1.
That is correct. On the 1.
Okay.
Dr. Henry, sorry to cut you short. That's where I'm a little bit confused. Why
Okay.
can't you say it's located on 2?
Because you always start where it starts off at. It's starting at the first carbon.
Okay.
So that's 1, 2, right? It ends at the 2.
Okay.
So that's why we have to number our carbons.
All right.
Okay. Okay. So then, tell me everybody's who's here. And remember, fluoro is going to be the last one because it's
Hello?
below. It's the lowest on the totem pole.
Right.
Okay, so tell me what's on the 5th carbon.
2.
2.
2 carbons.
We have, this is a 2 carbon, and this is also a
Carbon.
it's
3
also a
carbon.
So how will we name this?
5,5 diethyl?
Is it diethyl?
No.
Try.
Oh, it's 3 triethyl.
It's triethyl?
1.
Okay, slow down, y'all. Okay, so let's use a different color first. Okay, so this is 1, this is 2. This is just 1. Is it not? Maybe I'm wrong. You guys can correct me.
Wait, what?
Because I'm old, so I don't know everything. I forget stuff. So that's just 1 carbon, right?
Correct.
Right.
And this one has 2 carbon.
Correct.
Okay. So what is a 1 carbon called?
Methyl.
So this guy is going to be a methyl. And this guy is going to be a what?
Ethyl.
Ethyl. So you're saying to yourself at this point, so you're saying, Dr. Henry, I could have a methyl and an ethyl group at the same point. So how would I write that, right?
Mm-hmm.
So who has priority? So we're going to put that guy first.
Ethyl.
Ethyl.
Ethyl has more priority.
Okay, so. Or we're going to make sure that they have the lowest number. but yeah. And actually, it technically should go, the order should be, the ethyl should be closer to the base. So it would be, where's the ethyl located?
On the 5.
5 ethyl. Then methyl has priority over fluoro. So where's the methyl located at?
5.
And then finally, we have our fluoro. You guys get it?
So my question is, so for the longest chain, you don't have to put anything for that one since it's already taken care of with the octene?
That's right. We already took care of it here. We could have, there also what you could have done, you could have written it like this. I prefer this way, but this is also acceptable in IUPAC.
Oh.
That is also acceptable, although I think it's ugly, so.
So Dr. Henry, both ways are correct then?
Yep, both ways are correct.
Okay.
Yeah, the second way looks more confusing.
Yeah.
Yeah. Yeah, and the funny thing is that IUPAC uses both ways. So you'll see some people that do it this way, some people do it that way. I prefer it the other way because it's a lot clearer to me.
Mm-hmm.
The top way.
I have
Okay.
a question.
Yep.
In the previous problem, we put ethyl before methyl, and then
Yeah, that was my mistake. You always want to put the one that has the most priority should go towards the end. Kind of like when we say names, you know. So if you're Jessica, Inez, Gonzalez, Martinez. So the person that has the most priority gets the N at the end, you know?
okay, so we would go like in order, so like
Yeah.
methyl and then ethyl and then so on and so on.
Exactly, yeah.
Okay.
Yeah, and that was my mistake, my bad. Okay? Do you guys want to give another shot to another one?
Sure, why not?
Okay. And then we have 30 minutes left. You want to do groups after that? Or do you guys want to do groups first?
For one of these problems?
Yes. I heard somebody say Dr. Henry.
Okay, now question, what were you? Andy, where you get a fluoro from?
Fluoro, because that's an F right there. You see that F?
You know, yeah, but what kind of flower?
F? F is a halogen, so we just put an O at the end of it. So instead of saying fluorine, we just call it
It's on the
fluor.
chop.
What was that?
Wow, it's different. There's a different name too.
Yeah.
Oh, okay.
It
get
stands for
It's short.
fluorine. Even though fluorine is spelled a little differently, we just put the O as in fluoro.
Oh, okay.
Okay?
And yeah, coral. Oh, okay. Oh, okay, get it.
Oh, sorry. It's a typo. I forgot my U. It's fluoro.
Dr. Henry, I have a question.
Yes.
Is there ever going to be a situation where you have like two halogens attached to that, or would
Yep.
it?
There are always possibilities. That was one of my examples. You're stealing my stuff here.
Oh, no.
Fluoro. Thank you.
Oops.
I did tell you that I am not an English major, so spelling is not my strong suit. Okay, you guys ready for a shot? Want to give it a shot?
Yep.
Yeah.
Okay.
Let's see. That's the easy one.
And I'll remember to save the page this time. Okay, let's see. We'll give you a big bank of them, so you guys have to work a little bit, but not too crazily hard.
Ventano.
Okay, that's okay. Okay, and let's do
Oh my goodness. Man, you're really gonna put us to work, Dr. Henry?
right. You'll get it. Okay, so this is A, B, C, and D. Picture. Okay, you guys got it? Yeah, I'm constantly drawing, and I'm wondering why it's not drawing because I picked the wrong screen. So that guy in the orange box, that's my priority. Lowest priority is the halogens. The second one is the alkanes, then the alkenes, and then the alkynes. So we're increasing. This is increasing priority. And you guys understand what I'm saying by priority. The ones that are higher on the priority scale are more important.
Yes.
Okay. So let's start with A. Somebody help me out with A. What is my longest carbon chain?
I'll help. It's 8.
Okay. So 8. So that's 1, 2,
4, 5, 6.
3, 4, 5,
Get it now.
6, 7, 8. Okay. So my question is, I have a 2 carbon here, because this is 2 carbons, right?
Yeah.
And this guy is 3 carbons. So do I want to count in this direction or do I want to count in the other direction? Starting where the 8 is, and that'll be my 1.
Where the 8 is.
1.
The other direction?
Okay. 3. Why?
Because of priority?
Because of priority, that's right. And the priority will be the biggest chain in this case, right?
Right.
I'll fix my numbers here. Come on. Okay. You guys get it so far?
Mm-hmm.
Yes.
Okay, so then what do I need to do?
Well, you would have write out, would it be octene?
Would be the N.
Okay, you're saying OCTYNE is
No.
octene.
E-N-E.
Is it E and E?
A-N-E.
A and E. Why is it A and E? Why isn't it E and E or Y and E?
Because it's only a single bond.
Single bonds.
Because there's only single bonds here, so we don't want to put an A and E. Is that correct?
Yes.
Yeah.
Okay, so that's going to be at the very end. Okay, so what else do I have to work with?
Here for your 3 carbons that you have.
I heard something about my 3 carbon. That's
Yes,
4.
in
So
the
what will I call
4.
that guy?
4
Propyl.
Propyl?
Or propyl.
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 Okay, so that represents
And then you have your 5 ethyl.
5 ethyl,
Yes.
which would go before that. 5 ethyl.
Right.
And then
You have
4,5 dimethyl.
okay. And is that everyone?
Wait, Dr. Henry, for the
Yep.
4 and the 5 dimethyl, so that 1 carbon that is sticking out of the 5, you wouldn't count it going from 5 to 6, right?
No. So
Count the 1.
yeah, the one that's going from 5 to 6, that is all of this here. That's all part of the main chain.
Oh, okay.
Okay, so
Okay,
I'll
that-
draw the main chain in blue to kind of help
Okay,
you
that
guys
makes
out
sense.
in a small blue color. Maybe. Oops. Oh, what's happening?
Hmm.
I pressed the wrong thing. My bad.
Oh shit.
So main chain is right here.
Okay.
And so you don't want to overcount.
Right.
And so then my methyls, I'm going to do in yellow. Can you guys see yellow? So that's one methyl right here. And then this is my other methyl right here.
Wait, Dr. Henry, I have another question.
Okay.
So, and I'm pretty sure you answered it, but like for here, what? So you counted 1, 2, 3 that way because it gives you the what is it? The longest carbon chain, right?
Yep.
And then if you start like, let's say from here, that would be incorrect. Like, let's say you start 1 here and then 1, 2, 3, 4, 5, 6, 7, 8. That would be incorrect, right?
No, actually, that could be correct as well, but it just depends on what you have on your chain and where it's located, right? But that's 1, 2, 3, 4, and then you're saying 5, 6, 7, 8, right?
Yes. Yeah.
Yeah. So yeah, that could be correct as well, but it just
Okay.
depends on what you have on your chain afterwards.
Oh, okay.
But that does not seem right. 1, 2, 3. Oh, I guess there is the same either way. 1.
Yeah, it
2,
is.
3,
That's what I did.
That's
yeah,
yeah. That's why our group didn't.
3, 4, 5, 6, 7. So if we go 1, 2, 3, 4, 5, 6, 7, actually that would give us a better chain because we'd have smaller numbers. So that would have been the most correct. Issues with OChem. 1, 2, 3. Actually, no, it would be the same. 4. 1, 2, 3, 4. So methyl propyl, it's the same. It'll be the same structure. If I started with this chain or if I started with that chain,
Okay.
right? Because it would end up with the same 1, 2, 3, 4. You have a propyl, 1, 2, 3, propyl there, and a methyl. 4, propyl, 4 methyl. So it's the same chain.
Okay.
For purple. So 8 or 10, so 8 by
Yeah, so either you could have started here, you could have started here, or you could have started there. You ended up with the same name in this case. Doesn't always work out that way. We got lucky.
Okay. And if it didn't work out, like how would we know which one is correct?
You go with the one that has the lowest number with the highest priority.
Okay.
So propyl, because we could have went the other way, right? But propyl has more carbons than ethyl. So then propyl has a priority. So you want to make sure that that has the lowest number.
Okay.
So in terms of priority, this guy has higher priority than methyl, right? So if we had a really long carbon chain and we have 10 off of one of the sides, then that one would have the highest priority compared to a methyl group or an ethyl group. You guys get that? So think about it. Who's older, you or your siblings?
Me. I'm
You're oldest, right? So since you're the oldest, right? You were a priority to your parents because you were the firstborn, right? So you carry a bigger burden, right?
Yes.
Because you're the firstborn, right? So it's the same thing because you're older, you know, and that's the same thing. The one that's going to be the biggest or the oldest, or they're going to have the most priority. Okay.
Okay.
Okay. So you want to pay attention. Priority plays a huge part in it. Hierarchy is important in OChem. Okay. So does that help you guys? Did you guys have trouble? Did you guys finish them all?
No.
No? Okay. So what I'd like you guys to do, since our time is technically up and I have a meeting in 15 minutes, what I'd like you guys to do is to think about it. And then I want you to come up, I want you guys to give me 2 problems. One that you have of a stick figure, anything you want, right? You make it, it's yours. One is just a stick figure. And then I want you to do one that is the name. And then we have to figure out the name. So you have your assignment is to do this and to do that. You do this assignment, you'll get 5 points, extra credit points added onto your exam. If you don't come with that tomorrow, then you don't get those 5 extra credit points added onto your exam.
You want a stick figure and a word problem.
Yep. A stick figure and a name. And then, of course, finish these.
And finish those.
Okay?
Okay.
5 points. And you guys can work as a team. You know, you can work as together, but you should have different stick figures for your problem, though. You can't have the same stick figure
So
as your
one
buddy.
stick figure per group?
No, you have to
Per
have
individual.
each individual has to have a stick figure. And guess what? They may be on the exam if I like them.
So which one is my goal, doctor?
No, you don't have to work in a group, but I recommend that you work on finishing this
All
up.
those questions?
Yeah. So finish these questions, right? You can, and I'm saying you can work in a group, right? But when you turn in your problem, because you guys are making problems for us tomorrow, when you turn in your problems, then you should have one stick figure problem like this, and then you should have one that's a name problem like this.
Okay.
Okay?
Okay, thank you.
You're welcome.
All right, we'll see you tomorrow.
I'll see you guys tomorrow.
Thank you, Dr. Henry.
Okay? I'll see you guys tomorrow.
Thank you.
Dr. Henry,
Yes.
I have a question.
Uh-huh.
So when you have 2 halogens, would you go with the one that has, like, would you base it off the carbons?
So you always
In
base it off
each-
the carbon first. That's going to be your first priority. Where is it located on the carbons? That's one thing. And then
Okay.
you base it off of the halogens, right? So if you want to go with the smallest location on the carbons, right? But if you can't do that, then you go with the halogens. Then it's based upon who's the strongest. So, and fluorine is going to always be the strongest.
Oh, okay.
Okay.
So for that second structure that we have, I can see that we have a chlorine. So does that mean that the other one next to it is automatically a chlorine too? If
You're
it,
talking about for B?
yes, for B.
No, that means that this one right here is a chlorine, just it. That's
Oh,
only
just
one
that
chlorine.
one?
Yep.
Okay.
Yeah, that is just a methyl group. Otherwise, I'd put a Cl in front on top of it.